Good evening, everyone. Welcome to another chapter of the SSB Ground School. This one is on rope, which is a pretty critical part of our safety. We really need that rope, and it's a kind of thing where we don't want it to break unless we do want it to break. So it's got to have a lot of the right characteristics. And so tonight, we put together this presentation because we had a couple rope breaks about a week ago. And both of them happened right in front of the shack on the initial tow. When the tow plane put in the power, the rope broke, which is about as lucky a place as you could have for a rope break. But we can't expect our luck to hold out. So we've got to make sure we get things right with our rope. So for quite some time, Mike Exner has been our rope expert, and he has tested rope. He's defined its characteristics, and just been really helpful and really good. Mike's a very technical guy. And does a great job, and he understands how to measure things and how to rate things. Mike is not just an engineering type guru; he's also a pilot. He's has a glider and single engine land. He's flown gliders for about 1,200 hours. He's owned a number of aircraft, a few gliders and a few powered aircraft. And he's, more importantly, of course, he's contributions to SSB. He's a past president, a VP, a treasurer, which is a lot of work, ship manager. So at any rate, with that, I'm going to turn the presentation over to Mike Exner, who's going to talk about his analysis and measurements on our rope. Mike, please go ahead.
Okay. I'll go ahead and share this screen if I can find it. What I wanted to talk about today are mainly the tow ropes and weak links. There's, 7 elements to the tow system connecting the glider to the tow plane. But tonight, I thought we should focus on the rope and the glider weak link, since those are the 2 things that were relevant to these recent rope breaks. But at some point, it would be good to review some of these other things, the toast rings, which have some pretty tight performance limits. We had an incident recently related to a toast ring. The toast releases on each end. The E85s have a 2,000 toe limit before refurbishment. We'll talk about those things later, but tonight we're going to talk about the rope and the glider weak link. So first, let's sort of go over the desirable characteristics for a tow rope. We go through them pretty fast. So we need an economical solution, get a reasonable cost per tow. We need a durable tow rope, something that will last in our pretty rough environment. The SSB drags the tow rope rather than releasing it these days. We didn't used to do it that way, but we do now. And so that demands a rope of a type that has a very high resistance to abrasion, if possible. Because of our altitude and so forth, the UV resistant is important. Fatigue resistant is important. Moisture resistant. And torque free is really important from a practical standpoint. Handling the rope on the ground and winding it up at the end of the day and so forth. It's really preferred to have a braided type rope. Elasticity is another important attribute of tow ropes. You want some, but not too much. Nylon is very stretchy, it's very strong, but it's too stretchy. Some of the other high performance ropes available today are not very stretchy at all. And ultimately, we need a breaking strength suitable for using the bowline weak link. So there are a lot of choices out there. The first choice has to do with the materials, and the most popular materials out there today are polyester, polyethylene, polypropylene. There's a lot of variations on those, but those are the main ones. We've been using the polyester rope. Wings and Wheels calls it Dacron, but it's really a Vietnamese knockoff of Dacron. It's polyester, nevertheless. The polyethylene ropes are very, very strong. They don't have quite as much stretch, but they're extremely strong per unit weight. The polypropylene is the type of rope you see in the lower right-hand corner, and it's pretty much worthless for tow rope. It wears out so fast on the rocks that we have that it's just not a practical solution. Next, you've got different types of weaves, and we're presently using a hollow braid rope. Very easy to use in terms of doing testing on it. There's also double braided ropes and stranded ropes. A lot of stranded ropes, like the one you see in the upper right-hand corner, tend to not to be very friendly in terms of the torque feature, and they also have some wear issues. So there's a lot of variations here, but I think that general material and type of rope we're using, polyester and hollow braid, are really good choices for the SSB. The specific rope that we're using today is a polyester product sold by Wings and Wheels. Comes out of Vietnam. It's marketed as a 2,000-pound rope, but some time ago I measured the breaking strength and found it to be around 2,500 pounds. And I called Wings and Wheels and talked to them about that, and they went back to the factory, and the factory produced the data sheet you're looking at right now. So the factory confirmed the test data that I was getting. It's really a 2,400-pound rope. Keep in mind that any given specific piece of rope might break at plus or minus 5 or 10% of that. But a lot of test articles I've done puts it at about 2,400 pounds. So let's talk about glider weak links. There are mechanical weak links, particularly the Toast weak link. Some time ago, we tested Toast weak links at the SSB, and Bruce Miller tested some at Cloudbase. And we both ended up rejecting them because they're rather expensive and complicated to maintain in the kind of environment that we operate in. And Bruce Miller came up with this idea of using the single bowline weak link. The nice thing about this particular knot is that it breaks at a very predictable breaking point. In the rope that we are using, it breaks at about 50%, but I have seen it break in other types of rope as high as 65 or 70%. So it really is very much rope and rope type dependent. You can't just switch from one type of rope, say Dacron, to blue steel and expect to get the same percentage of breaking point. The most attractive feature about the bowline knot is that its breaking strength is nearly constant with exterior wear. That means you can drag it on the ground for 100 toes and it still will break at about the same breaking strength. The rope itself will be wearing, but the knot breaks at a point inside the knot where it's protected from the exterior wear. And the result is that these knots tend to break at about 1,200 pounds in the Dacron that we use, even after 100 toes. We've also looked at Mark's suggestion at the figure-8 knot. It was thought, based on a lot of climbing knot data, that the figure-8 ought to break at a little higher breaking strength, but we did not find that to be the case in this particular type of Dacron or rope. It's slightly harder to tie correctly. I've noticed just over the last week, a couple of the tow ropes presently in use have these figure-8 knots on the end, and they're not very neat. There's some loose loops on them. So it would be good to practice doing those figure-8s if you want to use them for the tow plane end. But they do have a predictable breaking strength that's similar to the bow line. So as I mentioned before, the actual breaking strength of this rope we're using is about 2,400 pounds. And that was measured by the factory, and I verified it on the fixture that I built here as well. The rope that broke, I think it was on May 29th, was breaking at 450 pounds. The weak link was down to 37% of the original. The implications are that rope in use last week broke at 900-pound tensile strength at the glider end. And it means we should really never cut and retie these weak link knots in worn rope. You can retie a knot in new rope, of course, no problem with that. But after a rope is worn, the worst thing you can do when it starts looking really ratty at the end is to cut it off and tie a new weak link. You've just reduced the weak link strength significantly when you do that. Be much better to just let the rope wear down to the point where it's around 60% of its new strength at the glider end, and then just retire the rope. But we should never cut and retie the ropes. That is why the second rope break occurred back on the 29th. It was tied in rope that only had a 900-pound strength, and that resulted in a 450-pound rope weak link. And if you're a little too quick on the throttle on the tow plane end, you get a little bit of jerk, and you're going to pop that at 450 pounds. So I took that rope that broke on May 29th and took some photographs of each end of it and the middle of it and compared it to brand new rope. And I then ran brake tests on those three segments, and here are the results. We're finding that even at the tow plane end, and this is maybe 5 to 10 feet from the actual tow plane end of the rope, was breaking at 725 pounds. New rope breaks at about 2,400. At the midpoint, it was already down to 1,120 pounds. And as I previously mentioned, at the glider end, the rope strength is down to 900 pounds. I've been trying to think about a way of advising people on the field how to determine when a rope should be retired. But certainly by the time it gets down to something that looks like that midpoint rope, that's time to retire it, because at that point, the rope itself is slightly weaker than what the braking strength of the weak link is. So this photo was taken yesterday, I think, or day before, on one of the operational tow ropes. And you can kind of get an idea of how fuzzy this is and compare that to how fuzzy these two are. So maybe that one's ready for retirement. I would also mention that some people have raised the question about whether or not the wear around the ring is something to be worried about. And I would just point out that the forces on the rope in this loop are only half of the forces on the rope in the main rope body. So it's going to be a very rare situation where this breaks, even when it starts looking pretty ratty, because the forces are half of what they are in the main rope. So let's talk about the club glider weights and FAR requirements here. This chart was made a year ago, so I'm not sure if it's still complete or accurate, but at that time, these were the numbers that I found. And if we go by the FAR requirements, the 80 to 100% rule for max gross weight, you can see that the braking strength of a brand new Bolin in our Dacron rope is a little bit low for the 505, and the others look like they're okay there. However, if you go to the pilot handbook, it specifies for these two gliders some different numbers from what the FARs require. And so we have some slightly different numbers here. It looks to me like it would be ideal if we could find a rope that breaks at 1,400 pounds. That would imply in a similar Dacron rope a 2,800 pound braking strength rope instead of 2,400 pounds. You know, we could debate whether or not it's important, but if we had a perfect world, I'd go look for this rope. So you might be wondering, well, how did we get all these numbers? Well, 21 years ago, I built the first rope braking fixture, and we broke a whole lot of ropes back then. It was calibrated with a National Bureau of Standards test sensor, and we calibrated it with that, and we got pretty good data with it. I'd say it was probably good to about plus or minus 10, 15%. But last year I decided to upgrade, and I went all out. I built a new frame and got a brand new hydraulic cylinder, a new bidirectional hand pump, pressure sensor, strain gauge, and amplifier, analog to digital converter, and a data collection system. So on the left picture, you see at the bottom the hydraulic cylinder. It's fully extended here. In this area here is a pressure sensor, and up here we have a strain gauge and a test article connected to the top of the fixture here. The next picture over is the hand pump. And this is a blow up of the, actually I have an analog and a digital pressure meter on the hydraulic pressure. And then the S-style tension measuring device here. The little amplifier here drives the A to D converter, which goes into the computer, which produces all the data so we can test articles like this. And what that gives us is an ability to capture the data as we pump up the hydraulic pressure, you can see the tension in pounds increasing. I'm plotting both the load cell pressure and also the calibrated hydraulic pressure converted to tension pounds. You can see they track very closely. This is how I basically verify that with a dual sensor system, I can be pretty certain that the data is correct and accurate. I'm estimating that the accuracy of the system as a whole is on the order of about plus or minus 5%. So you can see what happened here. This was a brand new piece of Teflon, not Teflon, Dacron rope, just like this. So there's a loop on one end. This will break pretty close to the native rope strength. And on the other end, I have a bowline. So, and you can see here, it got up to 2,400 pounds. And it sat there for about 8 seconds before it broke. I didn't add any pressure. I could hear it cracking, so I just stopped adding pressure at that point. About 8 seconds later, it failed. So that's the slide deck. And I guess at this point, I'd open it up for questions.
Mike, you should frame that picture and put it in the shack of the ropes.
Yeah, I'll do that.
Yeah, we need a good color photo of that. And so we kind of compare our rope. That be our gauge. That could become our gauge. Or, when that rope gets fuzzy, we need to toss it, don't we?
Yeah, I'm going to try really hard to quantify it in some way. I don't know yet how we're going to be able to do that. The only way I know for sure to test these things is through a destructive test process, but that's no good on an operating tow rope. We need some visual aids that will help people. It doesn't matter if the rope gets all the way down to 50%, it just will break at the same place. It would, not the same place, but it would break near the end, the glider end anyway. You might end up with 3 feet of rope hanging off the glider instead of none, but that wouldn't be a horrible thing. But you don't want it going down below about 1,200 pounds because, then you just don't have the strength you need for a normal tow, particularly, if you get into turbulence and the wave, wake turbulence, a lot of situations that could break that rope.
Just looking what I can see on the screen, I was trying to come up with a criteria that I could use next time I go out. And what it looked like to me was that if I could still make out the braid, it's fuzzy, but I can still easily make out the braid. That was about the midpoint. And then where it was really worn, I had, at least on the screen, I had to strain to be able to make out the braid because of all the fuzziness. So I was going to just say it's fuzzy, but if I can easily make out the braid, it's good. If I'm having difficulty identifying it, then chuck the thing.
Yeah, those are good points, and I'll try to, incorporate some of that into the little narrative I put with that photograph. I would also just add, just as a practical matter, this won't necessarily deal with FARs, but as a practical matter, consider the day. Do you have a day with, little to no turbulence, a nice clear day, not anticipating any severe turbulence? That's one thing. If you're getting ready to do a wave tow, you might want to consider being more conservative. So just a practical constraint.
And Mike, I've got a question. Is there a way that we could track the number of tows on any given rope? And I mean, that'd be awfully difficult to track, but if we could say, maybe a tow rope gives us 100 tows or 200 tows, and then we go by the number of tows on that particular rope and then retire it.
Yeah, we actually had that discussion a few days ago, and I've already set up some Google shared folders where people can drop photographs or of the rope condition at the end of the day and the number of tows. And we don't need to do this on an ongoing basis, but if we could do a little bit of data collection over this summer, I'm sure we would get a much better idea of how many tows you can expect to get out of a rope before it should be retired. And I think it's a great idea to collect that data.
Mike, Bob Lynn. You mentioned earlier an aggressive tow pilot, maybe going a little fast on the throttle. I'm sure Joe and I would never do anything like that. But have you considered or looked into a sudden stress test, such as hanging a weight on a rope and dropping at a specific distance so as to get a foot-pound measurement of the shock that the rope took?
Bob, I'm not sure if you were directing that at me. I didn't fully understand your question. You were asking if we should drop the rope? Negative.
Your testing is the same. I use the same test up at Owl Canyon when I'm there with a hydraulic pump and a steady amount of pressure exerting a force on the rope. Something that has bothered me for years is that ropes break with a sudden amount of pressure. And I'm wondering if you've considered in your testing, instead of just applying an ever increasing amount of pressure, hang a weight on the rope and then drop at a specific distance to get a, if you will, a foot-pound shock measurement.
Yeah, those are good points. What Bob is referring to is, you know, the shock load or the jerk factor. You know, dx dt gives you velocity, dv dt gives you acceleration, dA dt is the jerk on the rope. So if you're accelerating very rapidly from a stop with the tow plane, you're putting a lot of jerk and acceleration on the rope at the same time. And there's no way with the test fixture to that I have to really simulate that exactly. It's just a hand pump. So all I can do is increase the pressure gradually up to the breaking point. With all the tests that I've done though, I think, you know, the static pressure test is probably the best test for sizing the weak link and the type of rope we have. But it is important to keep in mind that, you know, these dynamic forces can sometimes exceed the static forces on an instantaneous basis. And I think that's the point that Bob's making.
That's right.
Or quite possibly, you know, the usual slackline recovery, if it's nice and gentle or if it's very, very hard. I mean, I've broken a couple of ropes on sloppy slackline recoveries, so I know how that happens.
Yeah, and in the instance of the 2 rope breaks that we had a week ago, I strongly suspect that the throttle up speed may have been a factor in one or both of those. Would also mention that I know for a fact, because the rope was retied that same day and broke again at 450 pounds, I know that one broke because the knot was tied in worn rope. I suspect, but have no evidence, that the same rope had been retied once before, and that's why it broke the first time.
Yeah, I was in the glider when it broke the first time. And I asked I was flying with somebody that I was instructing, and somebody was in the front seat, and I said, "Why'd you release?" He said, "I didn't release. I got out."
Yeah, well, it's good to point out too that that rope break, that first one took place in the heaviest glider we had with two big guys in it.
But it was also the first tow of the day. So that rope had come out of the shed with no, it had been used the day before. So I don't know, did somebody retie it the day before?
Hard to say. It might have been retied 5 or 10 tows before, and it didn't break until somebody tried to, tow a big heavy airplane with two guys in it, and maybe I think, is Mark with us today?
Yeah.
Mark, are you online?
Tow pilot. Yep.
I think Mark was the tow pilot that day, and maybe we should ask him what his standard practice is as far as throttling up. My practice, learned 50-something years ago, was always to get that slack out of the rope before you begin to throttle up. And then once you start to throttle up, don't do it instantaneously. Take 2 to 3 seconds to bring the throttle all the way to full power. And that way you really reduce the amount of jerk on the rope.
Mark, do you have any comments? Anything that you saw from your end, from the tow plane end when we had those two breaks? I don't know if Mark's, I don't know if his audio is working. His audio may not be working. Mike, here's another question I have. Let's say we take a brand new rope or a pretty new rope, and we go up and we're doing a checkout with somebody or lesson, and the rope breaks like it should on tow. Can we retie that fairly new rope or not?
On a brand new rope?
Yeah.
Yeah, I would say so. I mean, common sense here would say, if you haven't been dragging it through the dirt for 20 or 30 tows, if it still looks white, pristine white on the end, I would say it's okay.
Okay, good.
It's just a matter of common sense, really. A new rope is going to break at about 1,200 pounds. I wish it was breaking higher. Some ropes break it as high as 65% with the bowline, but for some reason, this so-called Dacron rope, it can break anywhere between 48 and 55%, and an average of about 50%.
All right, so
Mike, could you expand a little bit on why retying a knot on a worn rope is such a bad idea?
Expand on why we're using a knot?
No. Why would you say we shouldn't be retying the bowline at the end? Because I know, some people would, routinely, change the knot when they saw the knot starting to wear. So that's been kind of a practice that's gone on for years. And I'm really interested in understanding on a new rope, the first knot, and then on a worn rope, if you retie it, what's going on? Why is that such a bad idea?
Okay, I'm really glad you're focused on that, Gary, because if there's one takeaway from this whole presentation, it is that you should never retie a weak link knot in worn rope. And the reason is that, and I've probably done 100 tests of this, so I know it's a fact. Rope, the bowline knot will break at 50%, give or take a little, of whatever the strength of the native rope is. So if you take a rope that's worn down to the point where the native rope is breaking at 1,200 pounds, you tie a bowline in that, it's going to break at 600 pounds. If you wear it all the way down to 900 pounds, like we did last week, it's going to break at 450 pounds. And that's why we should not retie these knots in worn rope. It's easy to demonstrate. Done it many, many times.
Yeah, maybe said a different way is the reason the rope broke is because it was worn. And the rope itself worked its way down to where it's going to break with a knot in it. And so that rope broke because it was worn out and it broke. And if you retie it, you're just retying a worn broke, a rope that's going to break at that same strength that it just broke at.
Well, let's be careful and precise about that. It didn't break because the rope was worn. It broke because somebody tied a knot in worn rope. Had the original knot been left there and the rope wore all the way down to 900 pounds, it probably would not have broken. Because the knot doesn't wear, these bowline knots have a guillotine type function. If you look at as I have at hundreds of these things, if you look at how the bowline knot breaks, there's a loop around the rope and it squeezes the rope, and it literally squeezes the rope until it breaks. And that squeezing point, I call it the guillotine effect, is inside the knot where you can't even see it. It's completely protected from wear. The outside of the knot can wear substantially, and the breaking point in the knot will not degrade. And that's why you shouldn't retie it in a worn rope.
Thanks, Mike. That's what I wanted to hear, was that explanation. So thanks.
It's not at all obvious. And hey, I retied ropes for 18 years. 2 years ago, I figured out it was a bad idea.
Okay, do we have any other questions or comments? And I think we need to try to get like somebody suggested, get a good photo, get a good enlargement of that and in color, and we can code it or something and keep it in the shack but that.
Does anybody have a large format printer?
We can just take it to we'll just take it to FedEx, Kinko's, and it's,
Yeah, I can do that.
or whatever it costs, the club will pay for it. But you want to do it yourself, you reimburse, I'll go do it either way, but.
Well, I want to work on the annotation and make sure I try and incorporate some of the comments I've heard here to explain, because it's going to be hard to break the habit. I had a long talk with, or not a long talk, but I had a short talk with Joe Brack the other day about this, and he and I were both sort of like remembering how many years we thought that it was the best thing to do to retie that thing, and so there's a lot of tow pilots out there even today that just don't have this information. So we need to get the word out.
And just for reference here for everybody listening in, that rope, that length of rope, 200 feet of that Dacron rope that we buy costs about $45, $46. If we have a glider land out, it's going to cost us more than that. So, let's not scrimp on rope. Let's not.
Yeah, we shouldn't be pushing the limit. I'll try to get some visual aids that will help people determine when it's time to retire rope. But the key thing, again, if there's one takeaway, it is we don't retie knots, we retire the rope.
Sounds like we need to maybe have a couple of ropes more than we do now in the shed. in the event that we got a hot day going and we retire the rope, and then we don't want to get hamstrung measuring 200 feet and trying to find weak links to fit. So we may want to up that.
Yeah,
And that
I
may
was looking,
solve-
yeah,
that may
I'll have
solve the
Reed order another spool.
Yeah.
Yeah, I would second that. I think in order to try to change the culture a little bit in the club on retiring ropes, is, if there's another rope that's ready to go, or two at least in the shack that are ready to go, then maybe we'll get, tow pilots and glider pilots to say, I'm ready to launch and I want to go and it's a good day and it's time, but let's change that rope now. And and I think, like Joe just said, if you got a spool sitting there, guess what? It's not going to happen. People are going to continue to fly with the worn rope, and because they don't want to be the one that sits there for 20 minutes while they try to sort out getting a 200-foot cut and the tow strings, tied on and everything else. So I think we really need to have a minimum of 2 ready to go ropes in the shack at all times. And hopefully Reed can monitor that and make sure that, that condition remains. Then I think we'll get people to change the rope out. I flew the other day, and when Mike was taking a look at the ropes, and, he made a comment that one of the ropes we're using shouldn't be using this rope, but guess what? It continued to be used that day.
Yeah, and it didn't break that time.
Yeah.
I would second that, Gary, and I would point out there's another good reason for doing that. If instead of cutting off the weak links and retying new rope to the weak links, if instead of doing that, you simply kept the rope intact, retired it, give it to me, I'll turn around the weak links in one day and give you the weak links back, but we will get some very good data on where the rope is breaking at the glider end, the tow plane end, and the midpoint, and you'll get much better feel for when a rope should be retired.
Thanks, that's a terrific idea. Thank you, Mike.
I just wonder, Mike, with collecting the data, if you, when you come up with a rope that is just right on the verge of should be changed out, just marking and hanging the sample there in the shed. So you have the real thing in front of you to compare your existing tow rope to, and have the thing labeled so it doesn't get thrown out or, put somewhere else. Maybe an option.
That might be better than a photo.
Yeah, and be sure to notify me when there's one ready to be tested.
Happy to.
Leave your knife at home.
Any other comments or questions?
Mike, this is fantastic. And then I noticed in Soaring Magazine, there was an article on tow strings too. So combination of this presentation and your efforts over, God, my God, I'm probably old enough to remember when you started this, plus those articles is very timely for all of us to kind of refresh our memories. The first thing I need to do is go out and remove the single edge razor blade that sits on the end of the chain fence there that I used to cut the knot off so I could retie a new knot. It's still sitting out on the end of the chain link fence there by our start point.
Yeah, well, we'll get it right. It'll take a little bit of time, but we'll get the word out.
No, this is great. This is talking about changing our paradigm.
All right.
Before we end the session, I want to mention again that there are some other types of rope that are attractive that we haven't tried. I use Spectra on my raft, and it's great stuff. It doesn't stretch as much as Dacron, but it's very strong and extremely good on abrasion. And I think we can get some that's around 2,800 pound tensile strength. And if it breaks at 50%, that would be an ideal, weak link for our heavy gliders.
All right. So this is kind of an intermediate step, intermediary step, in that Mike presented some really great information. And now we got a couple things we need to do some more measurements on it. And we're going to attempt to keep track of how many times the rope is used. We'll see what we come up with, but it's good that we're focused on it, and the club's just going to continue to try to chip away at it and see if we can really understand this rope. But Mike has just been fantastic and instrumental in doing the engineering analysis on the rope and building that test rig and all that. That's great. So Mike,
Yeah,
thanks.
drop by anytime, and we have rope breaking parties from time to time. Ken Arnett and I used to get together and have cocktails and break rope just for the fun of it.
Well, I'll come over. You're pretty close to where I live, so
You've been there. You've seen how it
I've
works.
seen it. Yeah. So I'll come back over. But maybe we just use that rope that you've tested, because you had the end where the tow rope, you had 4 different stages of it. Maybe that's all we need. Is that those?
Yeah, I'll try to improve further on that. Maybe I'll test it at a quarter and 3/4 and put all of it up there so you can see how much it degrades over the
Yeah.
length of the rope.
Yeah.
We need.
Yeah, great. So anyway, Mike, special thanks for doing this. Really appreciate your work on this, and everybody else, thanks for contributing. And there's one chat message. We'll see what that is. How about actual rope? Yeah, so that's what we just talked about. Mike, I'll help you put together a board or something if you want, or I'll stay out of it if you want. But anyway, so see everybody at the field. Thanks for joining in, and good night.
Thanks again.
Okay, thank you,
Adios.
Mike and Armand.